Hello viewers out there, you are welcome to Senior Teleclass on Tech TV. This is Set 5. I'm going to take you through core mathematics, modular arithmetics. Last time we talked about the objectives. Today too, let me just repeat them. We are going to look at, or at the end of the lesson, students or you viewers out there, you are expected to be able to calculate the numbers in a given mod. In addition, you are supposed to be able to add and multiply numbers in a given modulo. Let's look at what we did last week. Last week, we learned how to find a number or a mod of a given number. For instance, if you have 8 in mod 5, and we said 8 in mod 5 is equal to 3. Why? Because 8 divided by 5 will give you 1, remainder 3. And we said we are interested in only the remainder. Also, we looked at how to find log of negative numbers. And we said if you want to find log of a negative number, you constantly add the mod to the given number until 0 or a positive is obtained. For instance, if we have negative 8 in mod 5, in this case, negative 8 plus 5 will give you negative 3. And then negative 3 plus 5 will give you 2, which means neg 8 in mod 5 equals to 2. Now, we started with the table small, but we were not able to reach where we were supposed to reach. So let's continue from the table. Tables in modular arithmetics. What do we mean by tables in modular arithmetics? Here, we are going to draw some tables for a given mod. You can be asked to draw a table of values for mod 5. Sometimes you'll be given specific values of mod 5 that you're supposed to use. Let's take a look at the first example. Draw a table of values for both addition and multiplication in modulo 5. And then the B part, when you are done with the table, you are to use your table to evaluate 3 plus 2 all times 4. And then I find the true set of a certain number plus 4 all times that same number plus 1 equals to 3. So let's look at how to go through this. I want you to write the questions down as I move to the next screen. In this case, we are going to rule some lines for the table. Remember we said mod 5, we have elements from 0 up to 4. So addition, 0, 1, 2, 3, 4. Then we do the same for the vertical axis or the vertical numbers, 0, 1, 2, 3, 4. What we need to do here is that, for instance, 0 plus 0, that is 0, then you write it there. 0 plus 1 is 1. 0 plus 2, 2. 0 plus 3. So it goes on and on. 1 plus 0, 1. 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. 1 plus 4, 5. In mod 5, 0. So at the end, you are supposed to get something like this. Okay, so this is the addition table for mod 5. Let's look at the multiplication one. That one also goes like this. 0 times 0, 0, 0 times 1. In fact, 0 times any number is 0. 1 times 0, 0, or any number times 0 will also give you 0. 1 times 1 is 1, 1 times 2 is 2, 1 times 3, 1 times 4 is 4, in that order. 2 times 1, 2, 3 times 1, 3, 4 times 1, 4. 2 times 2 is 4, 2 times 3 is 6, but 6 in mod 5 is 1. 2 times 4, 8 in mod 5, 3. 3 times 2, 6 in mod 5, 1. 3 times 3, 9 in mod 5, 4. 3 times 4 is 12, 12 in mod 5, 2. 4 times 2, 8 in mod 5, 3. 4 times 3, 12 in mod 5, 2. 4 times 4, 16 in mod 5 is 1. So this is going to be the multiplication table for mod 5. Now, the B part, we were asked to use our tables to evaluate first that's B, I. 3 plus 2 all times 4. So 3 plus 2 times 4. 3 plus 2, refer to the table. 3 plus 2 on the table is 1. Then you repeat the 4. Now you move to the multiplication table. 1 times 4 will also give you 4. And in all the time, you need to show it like what I have done. You can't just write the answer. We need to see this working. This will serve as the method, and the 4 there will serve as the answer. Here we were asked to find the truth set. N plus 4 times n plus 1 equals to 3. So what you need to do here is that you test with all the elements in mod 5 and see the one which will give you a balanced equation. On the other hand, the left-hand side equals to the right-hand side. So first, in place of n, let's use 0. That will give us 0 plus 4 all times 0 plus 1 equals to 3. We want to test whether the final answer will give us that 3. 0 plus 4 on the table is 0. Check from the table. 0 plus 1 on the table is 1. And now 0 times 1, we go to the multiplication table, because this time we are dealing with multiplication. 0 times 1 will give you 0, which is not the same as 3. So 0 is not an element. Then we go back to 1, where we see n. Let's write 1 there. And now from the addition table, 1 plus 4 will give you 0. 1 plus 1 will give you 2. And from the multiplication table, 0 times 2 will give you 0. But in this case, 0 is not equal to 3. So that is not an answer. We move to the next digit, which is 2, in place of n. This time, 2 plus 4 on the table is 1. 2 plus 1 on the table is 3. And now 1 times 3, when you go to the multiplication table, that will give you 3. And 3 is equal to 3. So this means n is equal to 2, because we tested with 2, but not the 3 that we have obtained. Instead, 2. because we tested with 2. Okay, so we write our 2 somewhere. The next digit is 3. The moment you get an answer, you are not supposed to end there. You continue with the rest of the elements. So this time, 3. 3 plus 4, all times 3 plus 1. We want to check and see whether that one will also give us 3. 3 plus 4 on the table is 2. And now 3 plus 4 on the addition table is 4. 2 times 4, that is on the table, is 3, which is the same as 3 that we have here. So it means in place of n, when you write 3, that will also give you a true statement. So you just write, therefore, n is equal to 3. Remember, we tested with the 3. Now you test with 4, which is the last element. Four plus 4 on the table is 3. 4 plus 1 on the table is 0. And now the multiplication 1. 3 times 0 will give you 0 from the table there. And is 0 the same as 3? Of course, no. So you just write 0 is not the same as 3. And for that matter, 4 cannot be an answer. We are done with all the elements, and what did we get? We had 2 and then 3. They gave us the right answers, or a balanced equation. So we just write the truth set. Normally we use TS to represent truth set, equals n such that n is equal to 2 and then 3. But we don't use n, we use comma because it's a set. And set elements are separated by commas. And this will be the answer for example 1. Let's quickly go through example 2. Draw a table for multiplication modulo 7 on the set P, which is equal to 2, 3, 4, 5, and 6. This time we are dealing with mod 7, but we've been given specific values. So we don't need to use all the mod 7 elements. We will stick to the values given. That's the set P. Then when you are done, you use your set or your table to find on the set P the truth set of n times, into bracket, n times 6 equals to 3. Coincidentally, we are still having 3 on our right hand side. It doesn't mean all the time it should be 3. So take note on that. Multiplication in mod 7. So here, multiplication sign, we normally circle it. Mod 7, by this time, selected elements 2, 3, 4, 5. 2, 3, 4, 5. Just as we did for the mod 5. 2 times 2, 4. 2 times 3, 6. In mod 7, still 6, because 7 is less than the mod. 2 times 4, 8. In mod 7, 1. 2 times 5, 10. In mod 7, 3. 3 times 2, 6. In mod 7, still 6. 3 times 3, 9. In mod 7, 2. 3 times 4, 12. In mod 7, 5. 3 times 5, 15. In mod 7, 1. 4 times 2. In mod 7, 1. 4 times 3, 12. In mod 7, 5. 4 times 4, 16. In mod 7, 2. 4 times 5, 20. In mod 7, 6. 5 times 2, 10. In mod 7, 3. 5 times 3, 15. In mod 7, 1. 5 times 4, 20. In mod 7, 6. And then the last but not the least, 5 times 5, which is 25. In mod 7, 4. So this will be the multiplication table for mod 7 on the set P. So I have, anyway, when you are done with the table, I think we need to move back to the B part. Let's check the B part. Use your table, I mean the table that we have obtained, to find the truth set of n times, then bracket open, n times 6, bracket close, equals 3. So once again, in place of n, we are going to test with all the elements given to us. So let's look at that one. This is the table. Now, n times into bracket n times 6 equals to 3. So in place of n, let's start with our first element, which is 2. 2 here, 2 there, 6 here, and see whether we get the same as the 3 over there. 2 times 6, you know, board man, you need to do the one in the bracket first. 2 times 6 on the table. In examination, if you write 12 before you convert, you will not mark, because 12 is not on the table. It means you are solving it without the table. You need to stick to the table, the values on the table. 2 times 6 on the table is 5. And now 2 times 5 on the table is 3. So you repeat the right hand side. You see the left hand side is equal to the right hand side. And for that matter, we can write therefore n is equals to 2, because we tested with 2. Right. Then you move on with another element. The next element after 2 is 3. So in place of n, write 3 there. Okay, 3 times 6. From the table, 3 times 6 is 4. And now 2 times the answer 4. 2 times 4 from the table is 1. And 1 is not equal to 3. So it means 3 will not help us. So far we already have 2, which gave us the right answer. Okay, let's start with 4. In place of n, 4. Okay, 4 times 6 on the table is 3. And 2 times 3 on the table is 6. 6. 2 times 3, 6. The first one was 4 times 6, 24, which is 3. Yeah. The third line. Okay. So now, 4 times 6 will give us 3 from the table. And now 4 times 3 from the table. 4 times 3 on the table will give us 5. And 5 is not equal to 3. So it means 4 that we tested with is not an answer. We move to the last element, which is 5. In place of n, 5. Okay, 5 times 6 on the table. And that is 2. And now 5 times the answer 2 on the table is 3. And you see this time around, the left hand side is equal to the right hand side. So we can say, therefore, n is equal to 5. So remember we had 2, that gave us true statement, and now 5. So let's write our truth sets. Okay. So now truth sets, we write n such that n is equal to 2, comma, and then 5, because these 2 gave us the right answers. So this is the truth sets. Okay, let's quickly move to example 3, or go to example 3. Okay. Example 3, copy and complete the multiplication table in Modulo 8 on the sets 2, 3, 4, 6. This time you are not supposed to draw the table. The table has been drawn for you, just that we have some sort of empty spaces. Fill there is the same as what we've been doing. Look at the empty spaces. For instance, 2 on 6, 2 times 6, that one has not been filled. So you need to do your own calculation. 2 times 6, and that will give you 12. 12 in mod 8, which is 4. So in place of 2 against or 2 times 6, you are going to write 4 there. So you follow all the empty spaces, you fill in with the right values. Try that one and let's see your answers. I believe you have your answers now. Okay, so let's now look at the answer. Look at your answers and compare to my own, and let's see. This is my answers for that one. Look at the red ones. These are the ones that I filled in. Compare to your own and let's see. I think you had the same. In case you made a mistake, you can just make the necessary correction. So this is the table or the solution to that question. Let's move to the B part. The B part, we were asked to use the table to solve the following equations. It's almost the same as the ones that we were asked to find the truth set. The same procedure. In place of n, write each of the elements and see whether the two, that is the left hand side, will balance with the right hand side or not. So let's check that one also. The first one is 2n times 4 equals to 3. I believe you have written that one. 2 times a certain number all times 4 equals to 3. Yes. Okay. So that's what we have there. Solve the equation. 2n times 4 equals to 0. So in place of n, let's write the first element 2 there. So in this case, 2 times 2 from the table, 2 times 2 is 4. And now 4 times 4. 4 times 4 from the table, that is 0. And 0 is not the same as 3. It means 2 will not work in place of n. Let's start with 3. 2 times 3 from the table is 6. And now 6 times 4. 6 times 4 on the table, that is also 0. And 0 is not the same as 3. Okay, let's test with 4. 2 times 4 will give us 0. And 0 times 4 will also give us 0. Even we don't have the 0 as an element on the table, it means automatically that one will not work. So let's move to 6. 2 times 6 on the table, that is 4. And now let's check 4 times 4. 4 times 4 on the table is 0, which is not the same as 3. It means 6 will also not work. In this case, it means the truth set is empty, or we don't have any element that will satisfy the given relation. So you just write the truth set like this, or you just write n such that, anyway, n such that n is an empty set. We don't write any elements, or none of the elements will give us a true statement. So we move to the B part, or the II part. No, that one we don't show it. It was supposed to work, but I made changes in the table. Okay, all right. The second part, or the II part, 2 into bracket 3 times n. Let me refer you to that question. So the second part, find the value of n for which n times, into bracket, 3 times n will give you 4. So let's check that one also. N times, into bracket, n times, 3 times n equals to 4. Okay, let's test with 2 in place of n. 2 times 3 times 2. Is it the same as 4? 3 times 2, 3 by 2, that is 6. And 2 times 6, 2 by 6, that is 4. So you see this time the left hand side is equals to the right hand side. You write therefore n is equals to 4. You have that in mind. You check with the next element, that is 3 in place of n. Okay, 3 by 3 on the table, that is 1. 3 by 1 on the table is 3, which is not the same as 4. It means 3 will not work. We check that of 4. Three times 4 on the table, 3 by 4 is 4. And now 4 times 4, 4 by 4 is 0, which is not the same as 4. It will not work. You check with the last element, which is 6. Three times 6, we always have to do the one in the bracket first. 3 times 6, and that is 2. And now 6 times 2. 6 times 2 will also give you 2, which is not the same as 4. So here only one element gave us the right answer, which is 2. So we move on with this time it wasn't truth set. You can just write, therefore, after showing this work, you write, therefore, n is equal to 2, and that will be your answer for this one. Let's move to the next example, which is example 4. Copy and complete the following table for multiplication modulo 11. The B part, use your table to evaluate 9 times 5, or into bracket, times 10 times 10. Then I find the truth set of 10 times a certain number m equals to 2. And then n times n equals to 4. Let's quickly look at the table. This is the solution. I want you to go through and then do it on your own and see whether you get the same table. Now that you have the table, let's look at the B part. I'm interested in the B part because I believe the A part, you can all do it now. So let's look at the B part. The B part first evaluates 9 times 5 times 10 times 10. Okay, let's go back to the table. 9 times 5 or times 10 times 10. Okay, 9 times 5, 9 by 5, and that is 1. 10 times 10, 10 times 10 is also 1. And now 1 times 1 will give you 1. So that is the answer for the B part. Okay. BII. Question A there. You have to find the truth set once again. 10 times a certain number, that is m, equals to 2. So let's finish with that one. Ten times a certain number m equal to 2. So in place of m, let's use 1. Okay, if you write 1 here, check whether 10 times 1 will give you 2 on the table. 10 times 1, that is not 2, so it means 1 will not work. We check with 5. 10 times 5 on the table, 10 by 5, that is 6, which is not the same as 2. We check with 9. 10 times 9, look at the table, that is 2. And 2 is equal to 2. So therefore, m equals 2. Sorry, 9. 9 gives us the answer. So 9 is one of our answers which we have in our minds. We move on with another element, 10, in place of m, 10. 10 times 10 from the table, 10 by 10, 1. But 1 is not the same as 2. So it means that will not give us an answer. We normally want to see the ones that will give you only the answers. So in examination, you can choose not to show how you test this one. The ones that gave you the right answers are more important. So right this time, we have only one answer there. So here, you just leave your answer. Remember, it's truth set. So you write truth set equals m such that m is equal to 9. Remember, it was m, so you need not write n. The I part, a number times itself equals to 4. This time our number is n. N times n equals to 4. Okay, let's test with 1. 1 times 1 on the table, is it the same as 4? Of course, 1 times 1 is 1 on the table, which is not the same as 4. So 1 will not work. We test with 5 in place of n. 5 by 5. 5 by 5 on the table is 3. But 3 is not the same as 4. Then we move on. In place of n, let's look at 9. From the table, 9 by 9 is 4. And 4 is equal to 4. So therefore, n is equal to 9. We have that in mind. We check with the other element, which is 10. 10 by 10 from the table. 10 by 10 is 1. And once again, 1 is not the same as 4. So we had only one answer, and that is 9. So you write the truth set. Truth set equals to n such that n is equal to 9. And that will give you the answer. Anyway, so this is the answer for the second part of the question. Okay. I have some exercises for you because of time. This is where we have to bring the lesson to an end. God willing, next week we will continue. Let's look at the questions there for you. Okay, let's look at number 3 rather. The other ones are on both combination of mod and then binary operation. That's what we are going to do, God willing, next week. So let's look at the exercise for this particular work that we've done. So we look at exercise 3. That's what we are going to do for today. Draw a table for multiplication in modulo 8 on the set 3, 5, 7. Only 3, 5, 7. Yes, this is what we are going to do, and you present it all. We will look at it next week when we meet, and then we compare to your answer. Okay, the second one, which is number 4, in this case, our second one for today. Construct an addition and then multiplication, both addition and multiplication tables for modulo 6. In this case, you have not been given the limit, modulo 6. So you use all the elements in mod 6. Use your table to evaluate. I'm interested in the B part. I know the table construction will be something so easy for you. Use your table to evaluate what we have on the board. That is first 2 times 4 plus 3. 2 times into bracket 4 plus 6 rather. 2 times 4 into bracket plus 2 times 6 in bracket. Then look at the C part. What conclusion can you draw from your answers in BI and II? Recall what you did in Form 1. Properties, the properties. We are dealing with the properties. Check whether I and II, in case the answer in I is equal to II, then what can you say? Is it going to be distributive property? Is it going to be commutative? Or what? Is it going to be associative? You know it better than I do. So viewers, this is where I'm going to bring today's lesson to an end. I believe you have enjoyed the lesson. Keep on doing the assignment. God willing, next week when we meet, we will continue with modular arithmetics and then binary operation. Remember, we have done binary operation before in real number system. This time we will link it to modular arithmetics. And that is also a very interesting topic. Okay, have a nice day and then goodbye.